Hello, my name is Mr. Asprey and this is Edexcel IGCSE Series 2. This is number 58, Kinematics. It is a topic which comes up at the back end of IGCSE papers, but I believe it is quite accessible. As long as we know how to differentiate, then we should be able to pick up a fair few marks on these questions. Okay, right, let's get into it. So I'm going to assume that you've watched my differentiation one and you know how to differentiate. Now, the trigger to know that this is a type of kinematic question is the words like displacement, velocity, acceleration, and also we tend to get a function in terms of t, which means that all of the values on the right-hand side are t's. And if I want to find the velocity, which is always the first step, because we start with displacement, which most of the time is s, but sometimes can be written as x. That gets differentiated to velocity, which then gets differentiated to acceleration. Okay, so that's the first thing I'm going to do. Whenever I see this kind of function of t at the back end of the paper, just differentiate it, get yourself at least 1 mark. So the 3 comes down, times by 1, and then we drop the power down by 1 to 2. The 2 comes down, times by -5, and then drop the power down by 1 to 1, which is just t, so we don't need to write it. And then here we've got t to the 1, and that times by -8 to get -8, and then we drop the power down to 0, and t to the 0 is just 1, so again we don't need to write it if we're timesing by 1. And then finally any constant at the end differentiates to 0, so it just goes away. Okay, we've got this. This is the expression for velocity, and it asks me when the object is at rest. So when it's at rest it has 0 velocity, which means we need to set the velocity equation equal to 0. Okay, we can factorize that, so I would always use the AC method, the Mr. Packer method, which is just awesome. So it's just 3 times -8, that's the A and the C term, and the B term is -10, so this is -24. So we need to then write 3t, and then all divided by 3, because the A term is 3, so we just do that, and then we'll set up, and what we need to do now is find 2 terms, or 2 numbers that times to make -12 and add to make -10. So that's -2 and, sorry, -12 and +2. We can divide this left bracket here by 3, so we're going to do it, and that will cancel the divide by 3 at the bottom. This is equal to 0. So we get t is equal to 4, or t is equal to -2/3. Now, of course, t can't be negative because it's time, so therefore the answer is 4. Okay, next question. This one's slightly more difficult because we've got to differentiate a function with a reciprocal in it, but that is always the first step, differentiate. So we need to write this out slightly differently as 4t squared plus 125t to the -1. That's because we've got 125 divided by t. So when t is on the bottom, it's the same as having t to the -1 in this case. Okay, so let's differentiate that because the velocity is equal to the derivative of the displacement with respect to time. That just basically means, it's a fancy way of saying differentiate it. 2 times 4 is 8. Drop the power down by 1 to make 1. -1 times 125 is -125. Drop the power down, goes down to -2. Now we want to work out the distance when v is 0. So what we need to do is find, well, the value of t when v is 0. Now to do this, whenever I've got a t to the minus something, I'm just going to multiply through by, in this case, t squared. So I'm going to times every term by t squared, and we're going to get a nice cancellation occur. So this is going to give me 8t cubed, and here I'm going to get -25. And then what do I get when I do t to the -2 times t to the 2? Well, I add the powers together, I get t to the 0, which is just 1. So I'm essentially timesing -125 by 1, That just gives me minus 125. So those t's cancel out. And anything times by 0 is 0. Okay, right, I'm going to solve this by adding 125 to this side. I'm then going to divide through by 8. And then finally, I'm going to cube root. And I know that the cube root of 125 is 5, and the cube root of 8 is 2. So I don't need to use my calculator to do that. So the time at which the velocity is 0 is 5 over 2, or 2.5 seconds. Okay, but it does say find the distance. Now, it's slightly confusing, and if you were to do A-level, then, or even if you do physics perhaps, we talk about distance and displacement. But I think for IGCSE, essentially they're the same. So when it's asking for the distance of P from O, it's asking you to find the displacement. So we're going to substitute in to the displacement formula the time which we just found, which was 2.5 seconds. So I'm just rewriting this displacement formula, but instead of writing T, I'll write 2.5. Okay, so I will do that one on my calculator. 4 times 2.5 squared. Is it plus? Yes, it is plus 125 over 2.5, and we get 75. Lovely. And that is meters, because it does say meters up here. Beautiful. Okay, next question, and once again we've got this displacement formula, and the first thing you're going to do, without even thinking, is you're going to find the velocity by differentiating this, and you're going to get yourself a mark. So that is 3t squared. The 2 comes down times by the 5 to make 10, drop the power down by 1. The 1 comes down times by minus 8, drop the power down by 1, gets t to the 0, which is 1, so we can just leave that alone, and any constant here differentiates to 0. And again it says at rest, and that means that the velocity is 0 when it's resting, it's not travelling at all. So what I'm going to do is I'm going to set this equal to 0. And this is very similar to the first question, and in fact it's not identical though, but it's very similar. And I know that we can put in here minus, oh no, how is this going to work? Okay, don't skip steps. Take your time, do the AC method properly. And that would give you 10. So we write 3t in both and divided by 3. And the two numbers that we're looking for, times to make minus 24 and add to make 10. And that is 12 and minus 2. Does that work? Yes, it does. Okay, we can divide the left-hand one by 3, and we can keep this one the same, and thus that is enough to cancel out the divide by 3, and this gives me that t equals minus 4, or t is equal to 2 over 3. Just by solving these brackets here, setting them equal to 0, and then just solving them. Okay, so it has to be this one, because we can't have a negative time. And what does it ask for? Well, it asks for the displacement again of P from O. Okay, well that just means I need to use my displacement formula, which is this. No problem. I just need to substitute in the time that I know is 2/3. So I'm going to get 2/3 cubed plus 5 lots of 2/3 squared minus 8 lots of 2/3 plus 10. Okay, I'm going to put that in my calculator. In fact, I'll just show you just a quick method. If you put 2/3 and press equals, then rather than having to type 2/3 out again, you can just write the answer squared, or cube, sorry, plus 5 times the answer squared minus 8 times the answer plus 10. So it gets me a bit quicker than having to type out 2/3 lots and lots of times. And that gives me that S is equal to 194 over 27. Beautiful. Okay, question 20, and once again we've got a displacement formula, so we're going to need to differentiate this. So the velocity is the derivative of the displacement. We're going to get 3t squared, we're going to get minus 18t, and we're going to get plus 33. This one's a bit different though. It says find the minimum speed. Okay, well we've got a formula for the speed or the velocity. Again, very similar things, and in all intents and purposes right now they are the same. They're not the same though, but we'll learn that when we get to A level. So I want to minimize something. If I want to minimize something, well then I need to differentiate it and set it equal to 0, because the minimum and maximums occur at the turning points, and that is when the derivatives are 0. So I've got a formula here which I want to find the smallest value of. So what I could do is I could differentiate it and set it equal to 0. And in fact, when I do differentiate it, I get the acceleration. So when that 2 comes down times by the 3, and then we drop the power down by 1, and minus 18t differentiates to minus 18. So I want that to equal 0, because that is going to tell me when the speed is at its minimum. So I've just literally written it out again. I don't know why I've done that. So adding 18 to both sides gives me this. Dividing by 6 gives me this. So when t equals 3, the acceleration is 0. But more importantly, the derivative of the velocity is 0. And that means that we are looking at the minimum speed in that case. And technically, it's because we've got a positive quadratic. So positive quadratics have a minimum point. So because this term is positive, we know that the turning point at this time here is a minimum. But it's asked me to find that speed, so I need to substitute in to the velocity equation the time which I've already selected, or already found, sorry, which is 3. Okay, so let's sub that in. Again, using our calculators, we've got 3 times 3 squared, minus 18 times 3, and then plus 33, and that gives me 6. Okay, great. Lovely. Okay, this one's slightly different. Displacement is given as x rather than s, but don't let that throw you. It literally means exactly the same thing. It says the direction of motion reverses when p is at a point on the line. Okay, well, even before I read anything, if I see this, I differentiate it, because that is going to get me a mark. So v is equal to dx by dt. 3 comes down times by the 4 to make 12. The 1 here times by minus 27 to make minus 27. And then t to the 1 drops to t to the 0, which we can just not bother writing. And this constant differentiates to 0. Okay, but now let's read the question. It says the direction of motion reverses. Okay, so let's imagine that the object is travelling along like this. Happy as Larry, just going along. And then it reverses at a particular point. Well, that means it's going to turn around like this. It's going to go back in the opposite direction. So in this instance, when it was going to the right, we could say that the velocity was positive. But when it's turned around and going in the other direction, the velocity is negative. So what happens at this point right here, this point A? Well, at that point, the velocity goes from positive to negative. So it means that the velocity must be 0 at that point. It must come to rest before it could start going back the other way. So that's essentially what it's asking you to find. The time when the velocity is 0. So we set our velocity equation equal to 0. We add 27 to both sides. We divide by 12. And then we square root. which is going to give me the square root of 9 over 4, which is going to give me 3 over 2. Just checking that's right. Yes, that is good. Okay, now we need to find the acceleration at that particular point. Well, how do we find the acceleration? Well, the acceleration is the derivative of the velocity. So we differentiate the velocity equation. So 2 comes down, times by 12 to get 24. Drop the power down by 1. And at minus 27 is a constant, so that differentiates to 0. So now I just want to find that particular acceleration at the particular time 3 over 2. So I sub in t is equal to 3 over 2, and this gives me 36. Perfect. Okay, this one is a tricky finale. So we have 2 different particles, and we need to find the time at which they're both moving in the same direction. Okay, so when we are doing kinematics, we can say that one direction is the positive direction, and if it's moving to the right, for example, then we can say that it will have positive velocity. And velocity has direction, so it can be negative, and that helps us distinguish which direction the objects are moving in. So if we have negative velocity, it just tells us that the object is moving in the other direction from the positive direction. So positive could be right, negative could be left. It just means they are different directions. So I need to find when each of these objects are moving with positive velocity and when they are moving with negative velocity. So first off, to find their velocity, I'm going to have to differentiate these functions. So I'm going to get this for the first one, and then for the other one, I will get its velocity is dx by dt, which is equal to 2t minus 4. Okay, now this one is a quadratic, so it's going to have this shape to it, like this. And that means that it's going to have positive velocity when it is above the axis, and it will have negative velocity, obviously, when it's below the axis, like that. So what we need to do is find the times at which it changes from positive to negative. And that happens when the velocity is 0. Okay, so we need to set this equal to 0. And we can factorize it. And we get, what do we get? We get minus 1 here, and we get minus 5 here. So that tells me that t is equal to 5 over 3, or t is equal to 1. Okay. And what about this other one here? When is that equal to 0? So this one is perhaps a little bit more straightforward, because what it will be is it's just a straight line. It's a linear line. So it will have negative velocity when it's below the axis, and it will have positive velocity when it is above the axis. And what we want to know is, when does it change over? Well, that will be when it's equal to 0. So that is when t is equal to 2. Okay. So let's what might be useful is plot these on a number line, because we're told we have to start at t is greater than 1. So we've got 1 there. Let's put 5 over 3 there. Let's put 2 there, and let's put 3 there, let's say. Okay. Okay, so this one, the quadratic one, what is happening to that? Well, it starts off positive, but actually 1 here is where it changes to negative. So in fact, it's negative, which we'll colour in green like this, between 1 and 5 over 3. because at 5 over 3, which is here on the graph, it changes. It's 0, and then after that it is positive all the way, like that. Okay, and what about the other one, the orange one? Well, this one starts negative, and it changes over at 2. So it starts negative, and it changes over at 2, and it starts being positive after 2, like that. Okay, so now hopefully it's easy to see when they are the same colour. It's between when it's between 1 and 5 over 3, they're both green, or when t is greater than 2, they're both yellow. And the bit in between, one of them is positive, one of them is negative, so they are not travelling in the same direction. Okay, hope you enjoyed that, and I will see you in the next one. Bye for now.